Greetings, ladies and gentlemen. Thank you for joining me. Welcome to TJ's Maths and Further Maths Adventures. If you're new here, thank you for joining me. The returning viewers, I really appreciate your support. In today's presentation, we continue with our solutions to theory of logarithm. With us here, we have two questions on the board. First question, given that log y power half to base 2 is equals to log 125 to base 5, we are asked to find the value of y. This is further mathematics, and this is WAEC 2007, number 8, objective parts. Question 2, given that log x minus y to base 3 is equals to 1, and log 2x plus y to base 3 is equals to 2. We are asked to find the value of x. This is further mathematics objective 2009, number 18. Let's look at how we can solve this. First thing to do, we'll write down the solution, as solution to 1. To do that, we are asked to find the value of y. To find the value of y, let's work on the right hand side. On our right hand side, we have log 125 to base 5. Log 125, I can write it as log 5 power 3 to base 5. From one of the laws of logarithm, if we have log a power x to base b, this is the same as x log a to base b. So we apply this law here. So it means we'll bring this 3 back here. That will be 3 log 5 to base 5. From one of the laws of indices, log 5 to base 5 is 1. So this will be 3 times 1, which is equals to 3. So it means this right hand side here is equals to 3. So we can write this as log y power half to base 2 will be equals to now 3, because log 125 to base 5 is equals to 3. So relationship between indices and logarithm. So we change this to index form. This is in logarithmic form. Now we raise this 2 to power what? 3. That will be 2 power 3 now will be equals to y power half. Our aim is to find y. To remove this half as the power, we square both sides. So we can take the square of this, then we can take the square of 2 power 3. These two will divide this based on power law of indices. So we'll be left with y, which will be equals to 2 power 3 power 2 is the same thing as 2 power 3 times 2. Then y now will be equals to 2 power 2, 3 times 2 is 6. The y will be 2 power 6. And 2 power 6 is the same thing as 64. That's 2 power 2 power 2 power 2 in 6 places. So therefore, the value of y now, which is 2 power 6, will be equals to 64. Because 2 power 6 means 2 power 2 times 2 times 2 times 2 in 6 places. That will be 64. So the value of y is 64. Okay, let's look at how we can solve question 2. Solution to 2 now. Let's move here. We write down the solution to 2. The first equation is log x minus y to base 3 equals to 1. We need to change this to index form. This is in logarithmic form. We have to change it to what? To index form. Very important. Then raise this 3 to power 1. That will be 3 power 1 will be equals to x minus y. X minus y now will be equals to 3. This is equation 1. As I said, we have to change this to index form. This is in logarithmic form. To solve for x and y, we have to change this to index form. The same to this other equation. We have this equation 1. Now the next equation is log 2x plus y to base 3 equals to 2. We raise this 3 to power 2. That will be 3 power 2 will be equals to 2x plus y. It means we have to change this logarithmic form to index form. 3 power 2 is 9. This will be 2x plus y now will be equals to 9. This is equation 2. So we have two beautiful equations here with two unknown. So we can solve these two equations simultaneously to find the value of x and y. But our target is to find x. But for us to find x, we have to solve these two equations simultaneously. Let's bring our equation 1 and 2 respectively here. So we have x minus y is equals to 3. That's equation 1. Our equation 2 is 2x plus y equals to 9. You can see clearly that we can use elimination method here. We can either use elimination method or substitution method. Let's use elimination method preferably. We can easily eliminate y. Why? Because the coefficient of y in equation 1 is minus 1. The coefficient of y in equation 2 is plus 1. So to eliminate y, we can add equation 2 and equation 1 together. So let's add this. X plus 2x, that will be 3x, minus y plus y will be 0. Then 3 plus 9, that will be 12. Okay? So we can easily find the value of x now. Here, we can easily find the value of x. We can divide through by 3. The coefficient of x is 3. Divide through by 3. 3 divided 3 is 1. We are left with x will be equals to 3 into 3 is 1. 3 into 3 means 3 divided by 3 is 1. 12 divided by 3 is 4. So the value of x is 4. The question says we have to solve for x. So we can stop here, or we can check for the value of x, for the value of y rather. We can find y. How do we find y? It's very easy. We can say put x equals to 4 into, let's say, equation 1. Or equation 1 is x minus y equals to 3. Anywhere we see x, we put 4. That will be 4 minus y equals to 3. So let's make y the subject of the formula. This will be 4 minus, this is plus 3. When you cross the equal sign, it becomes minus 3. That will be minus 3 equals to, this is minus y. When minus y cross this equal sign, it becomes positive y. Therefore, y now will be equals to 1. Because, let's move here. Therefore, y will be equals to 1. Because if we say 4 minus 3, that will be 1. So the value of y is 1. We can check. If we plug the value of x and y into this equation 1, will the left hand side and the right hand side be the same? Let's check. What's the value of our x? X is 4. What's the value of our y? Y is 1. 4 minus 1 is it equals to 3? Yes. The left hand side and the right hand side are the same. Hence, the correct value or the true value of x is 4 and the true value of y is 1. Thank you for watching. Please do share this to your learned colleagues, and don't forget to subscribe to my YouTube channel at TJ's Maths and Further Maths Adventures. Thank you.